So now that we know a little bit about significant digits, we need to know how to use them in calculations. And this is the key. I mean, this is really what is going to answer the question that you always all have. Where do I round? How many places do I round? My calculator says 4.39873468543. Where do I put the number? Well, here's where we know. Significant digits and calculations. You just punch it into your machine, it tells you this, and we can round. So there are two different ways in significant digits and calculations. First, if we have multiplication or division. So if we have multiplication or division, we're going to do it one way. If there's an addition or subtraction, it's going to be another way. I'll explain, I'll describe them as I go through, and again, I think the example will be the best in terms of describing how they're done. If you have multiplication or division, then the answer, when you multiply or divide, the answer has the significant digits of the one you used with the fewest significant digits. So the answer has the significant digits of the one with the fewest. So let's take a look at what I mean by that. So if I have a number, let's say I'm doing a volume formula. So my volume formula is length times width times height. And let's say that my length is 3.05 meters. My width is 2.100 meters. And my height is 0.75 meters. Okay? I multiply that on my calculator. I punch it all in. My volume is, it comes out as 4.803750 and it keeps going, okay? And again, this is be meters cubed. I'm a big labels fanatic, but it keeps going. I don't want to see that number on your answer. You don't want to write that down. Where do you round? Well, let's follow the rules. The answer, so down here, will have the significant digits of the one you used, so that would be these three, with the fewest. So we need to know how many significant digits in each of these. The first has, let's change this to a green here. Okay. The first one has 3 significant digits, right? Decimal present, Pacific side, first non-zero, 1, 2, 3. All right, 3 significant digits. This one has 4. Same deal, decimal present, first non-zero, 1, 2, 3, 4. This one, decimal present, has 2. No, this is not significant, and then 1, 2. So we have 3 in this one, 4 in this one, and 2 in this one, and the ones that we're using. And in multiplication and division, you keep the one with the fewest. So 2 significant digits. Therefore, this number should be rounded to 4.8 meters cubed, and that would be my answer. Now, the rules hold true for where you're rounding. If this would have been, and it's not, but let's pretend it was, if this would have been 4.87, etc., then yes, this 7 would have rounded this one to 4.9, and we would have kept 4.9 meters cubed on our answer. But yes, only 2 in our answer because the one that we used had the fewest of 2. So let's now move along to addition and subtraction. Addition and subtraction is a little bit of a different way of doing it. So let's take a look. When you use addition and subtraction in terms of how many significant digits, again, the answer has the significant digits of the one used with the greatest uncertainty. The greatest uncertainty is the one with the least amount of numbers to the right of the decimal. Again, probably not the best way of describing it, but I think hopefully the answer will, when I do it a problem, it'll show you. Let's take a look at a problem, and let's go ahead and grab this green one here, and we say we're going to add some things. 951.0, 1407, 23.911, 158.1800, and I've got one written out already so that I can 1021.1. Okay. Now let's add those all up. When I add those all up, just all 5 of them added up together, I would get 3561.2910. Okay, let's say that these were all in grams. I'm a gram fanatic or for labels, so grams. Okay, let's look at how many significant digits and figure out what this whole thing is. First, let's take a look at significant digits. There are, how many in this one? Well, in the top one. The top one has 4, decimal present, start from the Pacific, first non-zero, they're all significant. This one, the second one has 4, start from the Atlantic, 1, 2, 3, 4, there are 4. Here there are 5, here there are 7, and here there are also 5. If I was multiplying or dividing, very simple, I would have 4 significant digits. In addition and subtraction, we want to know what has the greatest uncertainty. The greatest uncertainty in this one, the least amount to the right. Well, that's this number right here. Why? Because the uncertainty on this one is plus or minus 0.1 to the 10th place. The uncertainty here is 1. The digit is the ones place. The uncertainty here is plus or minus 0.001. So the thousandth place. Here we've got plus or minus 0.0001 and plus or minus 0.1 to the 10th place. The greatest uncertainty, 1 is greater than any of these numbers. So very simple, we keep the significant digits of that number. So the answer will have 4 significant digits. Here it is, 3, 5, 6, 1, and I would stop right there. No other numbers, no decimal numbers, etc. Okay. Recognize again here that we did have 4 significant digits in both of those, but this is the one that we're following because it has the greatest uncertainty in this case of all these 5 numbers.